Okay, so this is going to be kind of a mini lesson on section 11.4, which has to do with equations in quadratic form. So quadratic form, it's an equation that can be expressed as a quadratic equation if we use substitution. And I'm going to give you several examples here to show you what I'm talking about. The idea is the variable factor in the first term is the square of the variable factor in the second term, and the third term is constant. For example, if I had x to the fourth minus 8x to the second minus 9 equals 0. Here's the variable factor in the first term, and it is the square, x to the fourth is the square of the variable factor in the second term. And my third term is constant here. So this is in quadratic form. Now here's how I've handled substitution. I'm just going to pick an arbitrary letter, and I'll use u, just because, well, just because. What I'm going to do is set your substitution variable equal to the second variable factor. What's being squared, basically. So what I'm going to do is, since that is my second variable factor, I am going to say let u equal x squared. This is where the substitution comes in. If u equals x squared, then x to the fourth would be u squared. I don't mess with the 8. X squared is the same as u. And now I have a nice friendly quadratic equation. Here I could solve this using the quadratic formula. I could solve it by completing the square, but I also notice that this is factorable. Multiplies to make -9 and adds to make -8. So this is going to factor into u minus 9 and u plus 8, giving me the solution u equals 9 and u equals -8. Now, keep in mind that I'm actually trying to solve for x. Once I have solved for my substitution variable, I'm going to bring x back down in here. So if u equals 9, u represented x squared and x squared. So now I'm going to solve this. Oops, I'm sorry, this should be a 1. My bad. Get ahead of myself here. So multiplies make -9, adds to make -8. That's a -9 and a +1. So x squared equals 9, x squared equals -1. I'm going to go solve for x here, so I'm going to square root both sides. And as always, when I take the square root, I have to consider a positive and a negative answer. So I'm going to get plus or minus 3. Same with this side, I'm going to square root both sides. And the square root of -1, that's going to be plus or minus I. So in this case, I get 4 answers. Okay, we'll do another one like this. Say I have x to the fourth minus 5x squared plus 6 equals 0. Again, if I square my middle term, I get my lead term, so I'm going to use u again. I'm going to set u equal to x squared. Then this becomes u squared minus 5u plus 6 equals 0. Now again, I have 3 choices on how I can solve this. Multiplies to make 6 and adds to make -5. That's going to factor into a -2 and a -3, which tells me that u equals 2 or u equals 3. Once I get u by itself, then I bring the x squared back in. If u equals 2, then that means x squared equals 2. Or if u equals 3, then x squared equals 3. To solve both sides, I'm going to square root both sides. Here I would get plus or minus the square root of 2. square root both sides. Okay, here I would get plus or minus the square root of 3. Those would be my 4 answers. Let's look at another scenario. Say I had x minus 5 squared minus 4 times x minus 5 minus 21 equals 0. Now it's tempting to multiply this out, distribute the 4, combine like terms, and you could do that. But again, this is my middle variable term. If I square this, I get that. So I can, again, use substitution. If I let u equals x minus 5, then this becomes u squared. This becomes 4u minus 21 equals 0. And I have a quadratic. And always looking to factor, multiplies to make negative 21, adds to make negative 4. That's going to be a minus 7 and a plus 3. So if I set u minus 7 equal to 0 and u plus 3 equal to 0, then I get u equals 7 and u equals negative 3. Okay, as soon as I get u by itself, then I bring x back in. Remember, u is x minus 5. So x minus 5 equals 7, or x minus 5 equals negative 3. I would add 5 to both sides. I get x is 12. I would add 7 to both sides. I get x equals 4. Okay, let's look at another type of problem. Say I have 5x to the 2/3 plus 11x to the 1/3 plus 2 equals 0. Okay, so I look at my middle variable, x to the 1/3. If I square that, I do get x to the 2/3. Here's the idea. If you took x to the 1/3 and squared it, according to the power rule, that would be x to the 2/3. So if I let u equals x to the 1/3, then this would be 5u squared. This would be 11u plus 2 equals 0. And again, now here I could use the quadratic formula to solve for u, complete the square, factor, do an AC method. I believe this factors into a 5u and a u, a 1 and a 2, and everything's positive. So if I set 5u plus 1 equal to 0, and I solve for u here, I would subtract 1 and divide by 5. So I'm going to get u equals negative 1 over 5. Here, if I set u plus 2 equal to 0, if I subtract 2, I get u equals negative 2. Now, I substitute back in and I say x to the 1/3 equals negative 1 over 5, or x to the 1/3 equals negative 2. Excuse me. Remembering rational exponents, x to the 1/3, this means the same thing as the cube root of x to the first power equals negative 1 over 5. Or the cube root of x to the first power equals negative 2. So then I'm going to, in order to solve for x, raise both sides to the power of 3, so cube both sides. Here I would get x equals, if I cube negative 1/5, I get negative 1 over 125. If I raise both sides to the power of 3 here, so cube both sides, I get x equals negative 8. Those would be my solutions. Maybe do one more problem just to see what's going on here. Say, let's see. How about go x squared minus 1 squared minus x squared minus 1 minus 2 equals 0. Okay, in this case, this is my middle variable term. If I square that, it would be sitting right there. So I'm going to set u equal to x squared minus 1. So then I would have u squared minus u minus 2 equals 0. Have my quadratic. This factors into u minus 2 and u plus 1, giving me solutions of 2 or negative 1. Again, as soon as I get u by itself, I'm bringing my substitution back in. So this would say that x squared minus 1 equals 2, or x squared minus 1 equals negative 1. Solving here, I would add 1, I get x squared equals 3. Here I would add 1, and I get 0. If I square root both sides, don't forget plus or minus. I get plus or minus root 3. Here, if I square root both sides, I'd get plus or minus, but plus or minus 0 is just 0. So in this case, I'm going to get these 3 solutions. So hopefully that's enough examples to get you through this section. Next week, we will tackle chapter 12.